Good afternoon, ladies and gentlemen of Bachelor of Two Honors. Good to see everybody here today. Good to hear reports about Jay from the SAT today, but we're going to go ahead and work on section 10.2, multiplying and dividing rational expressions. The section 10.2 is a follow-up to section 10.1, which was adding and subtracting rational expressions. So says essential question, how can you multiply and divide rational expressions? We're going to work on that today. And can somebody remind me of what is a rational expression?
It has a variable in the denominator.
Okay, Ben just said that it's an expression with a variable in the denominator. That's correct. That's what it is. All right, so let's go ahead and work on these. Does that ring a bell? Does anybody remember that before SAT preparation and all that? No, Julie is nodding her head. Yeah, Julie. And so we're going to start out by just looking at, we're just kind of review multiplication concepts. And so we have the question, how do you multiply 4/5 by 5/6? And it's really quite simple. What you do is you multiply your numerators together. So we have 4 times 5, which is 20. And we divide that by 5 times 6, which is 30. And then you simplify. They have it worked out. We're factoring all this. But 20 divided by 30 is? 2/3. Thank you, Julie. Yeah, 2/3, right? Okay. And so that's going to be the basic principle. And next, we're given this problem right here, and I'm going to rewrite it just a little bit larger. How can you multiply the rational expression? We have this here. We have x plus 1 over x minus 1 times your multiplication dot 3 times 2. And we have x plus 1 in parentheses. How do we multiply these together?
Could you cancel out x plus 1?
You could. Yeah, Ben says, can you cancel out x plus 1? You could. But before that, I'm going to pretty this up a little bit for the process. All right, so we're taking this, and we're going to rewrite x plus 1 over x minus 1, and I'm going to do this. What am I doing and why am I doing it with this?
So because that way.
So you know to do that before you.
You're treating as like one term.
Yeah, because if I don't do this, this thing might turn out down here as like x plus 3, right? And this is really not x plus 3, it's 3x plus 3. Because what do we have to do with this 3? Multiply the whole thing.
Right.
So now what can we do with this thing?
Multiply across. Yeah.
You can multiply across, and to multiply across, what I'm going to do is just this. I'm just connect these two fractions together. Now I've kind of multiplied across, haven't I, just by doing that.
Yep.
And then what can we do? What can we do to this here before we move on to the next or last step?
Cross cancel out.
Yeah, you look for like terms on the top and bottom, and I mean just like expressions, not like terms, like expressions. So we have this, and so now what we have is we're left with 3 times 2 x minus 1. And so this is our simplified, this right here in the bottom is a simplified version of the original that we were multiplying together. Okay? And so it's going to be this sort of process to do this. Okay, let's go on here. Multiplying rational expressions, and here they give these examples, more detailed examples of how to do more complicated ones. And I'm going to skip over those and just go right to your turn and kind of work through an example. problem, and then I'm going to have you work your own problem with this. So I'm going to work this out with contributions, I hope, from all of you, right?
Was that x squared at the beginning of it?
Yeah, this is x squared right here. So this is x squared minus 9 over x squared minus 5x minus 24 times x minus 8 over 2x squared minus 18x. Okay. Before I get started on this, do you have any ideas about what to do for this type of problem? It says find the products and any excluded values. We haven't talked about excluded values yet today, but do you remember in section 10.1 talking about excluded values? You remember that?
It's the value that makes the denominator of either fraction 0.
Yeah, so Ben says the value of x that makes the denominator of either fraction equal to 0. Okay? So that's where an excluded value is. And so we're gonna go ahead and we did that in section 10.1. We're gonna do it again here. Okay. Any ideas on how to do this problem? You have any ideas?
Simplify?
Yeah, that's like, can you simplify like the,
Go ahead, Peyton. What are you saying?
I was going, can you like simplify like the x squared or something like that?
Yeah, what we're going to do is we're going to go ahead where we can, and we're going to rewrite these things in factored form if we can, if it is factorable. So let's just go ahead and do that first of all. And so the first thing we're going to look at is this x squared minus 9. Can we rewrite x squared minus 9 in factored form?
Wait, hold on. Yeah.
Connor, what do you think this is in factored form is going to be?
It'd be x plus 3 and x minus 3, right?
Yep.
Because it's the, I can't remember.
Excellent. Okay, that's excellent work there, Connor. Thank you. Okay, so that's our factored form of that. And can we rewrite this denominator here in factored form?
Yes.
Okay, how do we do that? What is that going to be?
X.
We know we have the factors of x squared are x and x. We know that.
And one's plus, one's minus.
And that's the way I look at it too. And you look at that minus 24, and that tells you can have 1 plus and 1 minus. And then what is this going to be here now?
3, but plus 3
Plus 3
and minus 8.
and minus 8. Okay, now Ben gave us that, and my estimation is that he probably did that in his head, kind of. But one thing I've seen people in other classes do is they can actually just break this out and use a box method and kind of take a little more room to work it out. Okay, so you may do that too, right? As part of your problem-solving strategy. Okay, good job, first gentleman. I appreciate Connor and Ben participating. Now this thing right up here, this x minus 8, is that factorable? No, it is not. But I'm going to do this business here. Okay, now this denominator here, how is that factorable, or is it, and how?
Yes.
Yes. Well, what is going to be our factored form here? Somebody said, Kim or somebody said 2x, right?
2x.
X minus 9. One of these girls over here said 9. Who was that? Oh, Kim. Okay.
Yeah. Good job, Kim.
All right, Kim. Good job. All right. So, and now, and we can combine these into a single one by doing this, right? By just drawing across. Now let's go ahead and tackle the excluded values, since we can do that. Okay, what are the excluded values for this? Okay, -3. So x, I like to put it this way, x cannot equal -3. What others?
Positive
8. 8, okay, x cannot equal 8. Okay, Jay, how did you get 8?
8. Well, because you said -3, and then that's +3. So I looked at the 8, and it's negative right there, so it says +8.
Okay, yeah, so Jay is saying that if x is 8, you're divided by 0, right?
Yeah.
Good job, good job. Okay, what else?
0.
X cannot equal 0. And finally, x cannot equal 9. Okay? For the same reason, because if we have any of these things equal 0, we have an undefined expression. Okay, what next?
Hey.
If you cross out x minus 8.
Okay, cross out x minus 8. Here, Gabby, you say this. And this here too?
And the x -3 and x +3, right?
Well,
Cancel each other out?
well, x plus 3 over x plus 3, right? So these will cancel out. Okay, anything else we can cancel? Okay. Okay. So let's go ahead and just, we can put the final form here. So we have left x minus 3 over 2x, x minus 9. Okay? And x cannot equal all of these things. Now, I'll tell you one thing that certain math teachers that you might see when they write, I like to write it out like this, to list all the excluded values on the side like this. Some people will write it out like this, and what they'll do is they'll say x cannot equal 8 and x cannot equal -3. Okay, they'll just have only these two excluded values listed. Why would they just list these two excluded values here?
Because those are the ones taken out.
Yeah, because what happens is, these were the ones, these other ones, it's obvious, or should be obvious, that x cannot equal 0 and x cannot equal 9. So just by seeing this, you can see that 0 and 9 are excluded values. But I like listing them all,
Yeah.
right? Because I think it's just a clearer statement of, because what you're doing in your work is you're communicating that work to someone else, a teacher or someone, whatever. It's just clearer. And so that's what you have, and that will be your answer. And that's it. Any questions on this? Okay, what I'm going to do is I'm going to give you a problem to work out. And I will tell you, as I go to this problem, I want you to work out. I got some complaints during 7th period that this one here was really easier than the one I did originally. So it may look easier, but the concepts are still what? The same. Okay, so I want you to work this one out. Can you imagine students complaining about having an easier problem to work out?
I don't know anybody that would do that. Was it Brian or Steven?
Let me see here. It was one of those two.
Yeah.
Those guys were, and here's the thing about Brian, is Brian came in here, said, I'm all exhausted from the test. I've been testing all day. My brain doesn't have another ounce of energy. And he came in here all class. He was just answering questions, and he just couldn't help himself.
You're just killing it.
Yeah, he was killing it. So Brian did a great job, and Steve-O did, and Jace, and let's see, I think Victoria had a question. So it was good. 7th period was a good class today. Oh, I do want to mention one thing that this class did, that the other classes had a little problem with, is some people in the other classes were saying x cannot equal 3. Okay, what they were doing is they were looking at the numerator,
Oh, yeah.
because the numerator can be 0, but the denominators cannot be. So therefore, 3 is not an excluded value. So anyway,
Rewrite this like this.
Or things, you can simplify it.
Oh, I didn't even see something like that. And X.
Yeah.
Yeah, you have to. So then, you connect it. Then you see if you can like it out.
So that's just x, oh, 30x, yeah. Over, that's just the answer. X can't equal
What did
2.
you say, X?
Or.
9?
Or 0.
0 plus 1 is 1. 0 minus 1 is 1.
So this is minus.
Did I drop that? Oh, it's like, because I was eating those too.
I think it's about doing this. Haha, Addie, I finished the problem before you. I think that's what math's about.
X can equal 0 or not?
Well, you put in x as 0,
Because,
so like 0 minus 9, exactly, that's negative 9.
it makes sense then,
Yes.
So that's,
but actually,
that's what you just plug in numbers.
Okay, but what if that was a positive 12? What if it was x plus 12?
well, then it wouldn't be.
Well then,
Like, what if that's, instead of x minus 9, what if it said x plus 12?
well then.
Could x equal 0? How do you know? Does it have to equal negative 9?
No, that's an excluded value means equal.
Okay, yeah, no, but like, you said just plug in 0 for x, and that's negative 9. But what does that mean?
It means that 0 is not an excluded value.
But why? Because it equals negative 9?
Yes.
Is it just because it equals a negative number?
Once you simplify everything, the bottom number cannot be 0. So negative 9 is not 0, right?
Right. Oh, so this can equal 0.
Yes, it can equal 0. Like x can be 0, but the
Okay, so then if you don't mind, can you run through that all like about 5
Wait,
times?
so how would 0 ever be an excluded value unless the bottom number was 0?
well, if you multiply by something, like the last one, you're multiplying by something, 0 times 2 is 0, 0 times this is 0.
Okay.
So that's like the only,
Yeah, it's the only way.
So there's just
usually
one
get that.
excluded value.
Those two.
Can I put in
Which one did you get?
-1? X can
Okay.
equal -1.
okay, we're gonna bring it back here. Okay, there are a lot of good things about this class that I like, but maybe the best thing I like about it is there's good discussion and helping each other and debating. I mean, you guys are some good debaters and so forth, so I really appreciate that.
I didn't catch a word that you caught, you said.
I get it now.
Now, we're gonna do this, and then we can,
So if there's a 12 there.
So if there was a 12 there, Jay, what's the answer?
so,
X could equal 0.
Okay.
so right now, I'm gonna rewrite this as x over x minus 9, and times, and so I put x plus 1 like this, and so these three things here, I don't see any way to factor these at all, right? So you're kind of just stuck with where you are.
Yeah.
But what about this thing up here?
Yes.
So how is that factorable? X minus 9, right? Okay, and then we can go like this too, right?
Right.
Because everything's in parentheses. And what are the excluded values?
Hold on, let me think.
X cannot equal 9.
Oh, x cannot equal -1 or 9.
Yes.
X cannot equal, and one thing you can do is that, and the way Jay mentioned it, he mentioned those two, so I'm just going to put these in set notation. X cannot equal, did you say -1 or 9?
Correct.
So you can write it in set notation like this, if you want to, okay?
Good.
All right, so that's the way Jay said it, so I just kind of wrote it the way Jay said it. Okay, what next?
Take out the x and then get 9.
You take out the x minus 9, right? So what do we have left here?
X times 3 over x.
You have 3x over x plus 1. Okay? So our answer is this 3x over x plus 1, but x cannot equal -1 or 9. Now I had a student in 7th period, I think it was Steve-O, who graphed both of these expressions. He graphed this one here, and he graphed this one here, and he said that they looked exactly the same, except he went to the table view, and what did he see?
Something different.
He saw something different. He saw an error where x equals 9 when he did this,
Oh, Steve.
but not here. Why would an error appear up here for 9, but not here for 9?
Because 9 doesn't equal 0, or doesn't make the denominator equal 0.
Yeah, on the bottom here, there's nothing that would indicate 9 as excluded value, right? And so the calculator sees it that way too. And so, anyway, so that's something to take into account. And we call these, in pre-calculus, we call these excluded values, we call these function discontinuities.
It's a big word.
Yeah, it is. It's a big word to impress your friends and or whoever you want to impress. In a job interview, something like Jay, you can bring up discontinuities. You can talk about extrapolations and interpolations and discrepancies. So that's one thing that mathematics can do for us. It can give us a vocabulary of words if we want to impress people, right?
Yeah.
Okay. I don't know if you've ever done that. I know some of you do that unintentionally, maybe. Okay. Any questions on this? All right, we're going to go ahead and go into dividing rational expressions. And when in summer school, I taught 7th grade math many years ago. I had I was introduced to what students learned during 7th grade. And I heard from Mrs. P. Cowell, who I talked to the other day, that now they even introduced this concept earlier into 5th and 6th grade.
What?
Anybody have Mrs. P. Cowell for a teacher? You had her for a teacher?
Yeah, that's it.
All right,
You
so
drop your apple juice.
anyway,
It's actually water and it's also not.
so anyway, the principle is this. Okay,
Guys,
okay, principle is this.
bring it back.
Dividing by a fraction is the same as multiplying by that fraction's
Reciprocal.
reciprocal.
It'd be like, no.
Atta boy. Give that man a high five. Yes, sir. Oh, yeah.
All right.
Ain't nobody got one up yet.
Yeah, what it is I think the it has to do with mandates. All right. I used to do that a lot more before last year. Yeah.
Gonna dig in.
What's the exponent on the x on the denominator of the right fraction?
2, that's a 2, right? So what it is, we're going to do a rewrite, and basically the strategy, these division problems are very similar some multiplication problems, except we're going to be dividing by, we're going to go ahead, instead of dividing by this, we're going to multiply by its reciprocal. So what we're going to do is we're going to take this denominator here and put this up here in factored form, and we're going to take this denominator here, this numerator here, and put this down here as a denominator. So I'm going to call that 2x plus 3. Does that make sense? Does that make sense? Questions on that?
No, it makes sense to me.
Okay, good. So what's going to be our factored form of this thing here?
X plus minus.
Plus minus. It'll be 3 and 1, right? So one's going to be 1, one's going to be 3, right?
So plus 3 minus 1.
Plus 3 minus 1, does that look right?
Yes, because 3 minus 1 is 2.
Yeah, so, okay, now before we go ahead and simplify this out, let's go ahead and list our excluded values. Okay, so x, what are the excluded values here?
0.
X cannot equal 0.
No, we can't.
X cannot equal
Negative 3?
Right.
negative 3. Is that it?
Four times what equals 0?
4 times 0 is 4.
Yeah.
Well, yeah, obviously.
Yeah, so Addie, was that your question, Addie?
Yeah.
Yeah, so what you have is you have 4x cannot equal 0.
Everything times 0.
So if you divide by 4 to solve for x, right? So you get x, you end up with x cannot equal 0. So the takeaway is whenever you see a number attached, like multiplied, 0 is still your excluded value.
As long as
Right.
by itself.
Anytime that it's
Yeah.
multiplying, it can't be.
Yeah,
Well, yeah.
okay? So that's kind of the mathematics.
That's the law of this.
Okay, is there any other excluded value?
Yeah, you made sense.
Okay,
I don't
Right.
think so.
okay, Jay says he doesn't think so, okay? I'm going to tell you there is one more excluded value to this.
Oh, nah.
Would it be 1?
What do you say?
Would it be 1?
Okay, let's talk about this here. Because Peyton says x cannot equal 1, right?
That would,
That was
Oh, yeah, it is 1.
Well, tell us why x cannot equal 1.
because I guessed that number.
Oh, really?
Yeah.
Okay, you guessed it, right?
Ben, tell us why x can't equal 1.
Well, you plug in 1 into the fraction.
You'll just plug it.
Okay, here's the reason, okay? It has to do with the original.
Yeah.
So what it is when we rewrite like this, now this is our denominator, but originally this was our denominator, right?
Right.
And when this was our denominator, the factors of this thing were this, and so x can't equal 1 up here. So in this case, you got to look at the original and see what it could not be. So this drags in another excluded value, doesn't it?
Yeah, I forgot we did
That's
that.
That's why I told Connor, I was like, I don't know
Actually,
about that one, I didn't know if that had anything to do.
Yeah, so that's good. So that's some good work, guys. Some good work, Peyton. Ben, all right. All right, now let's cancel out what we can. What can we cancel out? X plus 3, x plus, can we cancel anything else out? I'm not seeing it, right? So we have x plus 11, x minus 1 over what do we have left in the denominator? 8x. Okay, and these are the excluded values, and that is our answer. All right? Are we okay on this one?
Yes.
Okay, what I have here is I have for remainder of class is to work out this one here. Just work that out, and then we'll, in a few minutes, kind of review it together, all right?
Is that another x squared?
Yeah, that's an x squared. Those are all x squareds.
Any other number?
Yeah.
Always, sometimes it's x cubed.
Yeah, it could be an x cubed, right? So that's a good question.
There's a rule that it can only be x squared, and it's x squared, it shows an x above the
There's actually no x above the 2, the 2's above the x.
two. If you look at it really
If you're just-
close,
If you look at it upside down,
If you're just looking at it,
Exactly.
it's not.
yeah, from my angle, it's upside down.
oh, okay, I see it.
While you're working on this was a good class today. I appreciate everybody who contributed, which was pretty much everybody. Marcus,
Except for
Peyton, Connor, Jay, Ben, Kimmy, Julia, Addie, everybody had something
Everybody, I don't
to
think
say.
Gabby said anything.
No, she did. She did.
Yeah,
She
you
did.
did say stuff. I
Yeah,
said, cross out the exclamation.
Yeah, she didn't talk a lot, but she did talk and contribute to the
You're just
discussion.
saying the same thing.
No.
So everything's a
Something small.
You don't have to talk a lot to be a contributor, do you?
No. Because Peyton talks a lot and he never contributes to anything.
Wait a minute. Oh, this is an indictment of a fellow. This is an indictment of a fellow.
Yes.
This is an indictment of a fellow muscle man. This is not a lot of loyalty right
What does it
here.
even mean?
It's a very multi-layered problem.
Kind of yeah,
Yeah.
it is, yeah.
I haven't got past the first layer.
Okay, I'm just gonna be quiet for a
I always get no onions, so I don't know how to do it.
So I just figured out how to write it down.
I figured out how
I
to
just
talk
figured out how to
about
spell those numbers.
Yeah, this is the last of the rest of
I don't know how to spell numbers.
I don't know how to do
That
this.
one was
Let's open and go anyway. I think it's like working. They got
It probably is.
It got on me.
There's no way.
You're gonna do it.
I think since we're running a little short on time, in a couple minutes, I'll just work it out. And if you find that I made a mistake, you correct me, okay?
No, you pushed it off my desk.
That would definitely.
That's actually yours, but give it to me.
Oh, you bought this alone, so you can take it.
I don't sit with you either. That's why. I saw you carrying it in the hallway.
Well, shove this down.
I'll still like
Take
it.
it off.
I'll still like it.
So make sure you get the item in here.
No.
Let me put the Z.
When you do the item in here.
No.
Well, I already had an item.
No.
Sorry, I thought you were.
I just said.
I think
It says,
I think.
hey, I'm trying to solve the problem.
Present.
Distracting me.
I think it's
That's not right. Ah!
Well, you get up on the line.
And draw them on your, as big as you can.
Oh, like, cracker five now?
Yes.
That's a head, it's obviously not a.
That's not a head, dude. That's a balloon that got tied off with a piece of string. Just do not.
Well, you can square root it.
I don't have to.
What's square root it for?
Here, Eddie.
Okay,
What two num, what?
I'm just gonna write,
Yeah,
I'm just gonna rewrite this thing here.
Stays too sharp.
So I'm gonna rewrite this as 20,
It was.
You're rejected.
and I'm gonna factor this in the new denominator, x minus 7. And then what I'm gonna do is I'm gonna multiply and put the factored form of this one in the numerator and the factored form of this numerator in this denominator. So here, I'm going to get, in the denominator, I'm going to get 5x times x minus 8. Okay, you see that's the factored form of this? And here we're going to get x, and we have, that's positive, but that's negative, so I'm going to have a minus minus somehow. And I think that, is that 7 and 8?
yes.
7 and 8. And then I'm going to go like this. And excluded values. we're going to say x cannot equal 7, x cannot equal 7, x cannot equal 8, x cannot equal 0.
Told you, Ben, you dumb, silly head.
See, x cannot, because neither of these x's can be 0, right? Any other excluded values?
I don't see any, if there are.
That should be it.
Now, what happened is, we could look at this up here,
But it's the same as bottom.
but they're already accounted for in what we found here. So there's nothing new to add by looking at that, right? So now what can we do? Cancel, 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 cancel. And so, looks like 20 over 5x squared. And can we simplify this further?
Yeah.
What is this going to be?
2 over x. Like 4 x
4 over x squared.
and then 8 to 8 more, or not?
Now, you said, that's what happened, we had a student, a really good student, Rindy, you know her, right? Second period. She recommended taking the square root of both of these, but there's really no reason to do that.
I was number
Yeah, okay. Well, that's mark a good student, thinking of what to do next.
But you can do it though, and it would still be right?
No, it wouldn't be right, because that wouldn't be an equivalent expression to that, because, right?
So how did you write?
Okay.
All right, thank you, class. Look forward to tomorrow. We're going to work on the exercises.